Hello everyone, I'm going to do a quick video on Internet Control Messaging Protocol. Welcome to Networking Lessons by Siddharth Tiwari. Now, when we talk about ICMP, it is a very important protocol. Why it is important? First of all, ICMP is a network protocol used for diagnostic and network management. Now, without diagnostics, you cannot really find out what the problem is. So I'll give you an example. A good example is the ping utility, which uses an ICMP request and ICMP reply message. When a certain host of port is unreachable, ICMP might send an error message to the source. So if you don't know what ping is, well, anybody related to networking normally knows about ping. But if you do not know about ping, the whole full form is Packet Internet Gopher. It is used to check the connection. Say, if you go to command line and type ping space google.com, you should get 4 packets as a reply. If you get 100% reply, means all the packets have been sent and received. If there is a loss, it shows you the loss. So that actually tells you that the internet or the network up to the Google server is working. Now, Google server might be located on a different continent, so you are basically accessing the Google server via the internet. But if you have a local router located in a different room, you can, and there is a switch in between, or there is another router in the same room, and you are accessing the third router, which is in a second room. You can check up to each router if the connection is working or not. Let's say if you're checking the connection up to the same router in the same room and it's working, fine. So you are connected to the next router, and when you check the other one in this, like say the second room, it's not working. So you know that your link from your place to the router in the same room is working. So you go up to that router and check the link between that router and the router in the second room. And if that link is working, so you can ping from that router to the other router and see if they are both working. So if the both of them are working, then there is a problem with the link. And with your device which is connected to the router, so that is working. And if the other one is working, then the router in the middle is not forwarding your packets. So you have to check the configuration. So ping is a very important utility. Another important utility is traceroute. Traceroute is also an example of ICMP. Now you might want to check, let's say if there is another router in the same room, and you are checking the wrong router, so how do you know where the packets are going from? So you go on your command line and let's say type in traceroute space 192.168.1.4. Now the 4 is working through another router, so all the time you're checking the wrong router if the link is working or not. You go to the second router and you see that okay, there is the problem, that link is not working. You fix that and it's working. So this is how traceroute works. You know which router the data is going through. Now the ICMP messages are encapsulated in IP packets. So most people would say that it's a layer 4 protocol like TCP or UDP. However, it is not. Why? Because since ICMP is a vital part of the IP protocol, it is typically considered a layer 3 protocol, the network layer. The headers that ICMP uses is really simple. There are 3 fields: type, code and checksum. Now type and code are very important. I'll tell you about them. The remaining header depends on ICMP type. So whatever the type is, remaining header will be dependent upon the type. And the first byte specifies the type of ICMP message. For example, type 8 is used for an ICMP request. I'll tell you about it. And type 0 is used for an ICMP reply. So if someone is requesting you for ICMP, then he is sending the first byte with a type 8, and when you reply to it, you reply with a 0. So when the other end, the host or the router, sees the type 0, it knows it is ICMP reply. We use type 3 for destination unreachable messages. Let's say when you type in ping google.com and you get a message called type destination unreachable because you are not connected to the internet or there is some problem. How do you know there is a problem? You know that because it comes with a type 3 reply. Type 3. And when there is a type 3, it means that destination is unreachable. And the second byte, called code, specifies what kind of ICMP message it is. So we learned about the type, like type 3 is destination unreachable, type 0 is reply, type 8 is a request. The second byte actually is a code that specifies what kind of ICMP message it is. For example, let's say the destination unreachable message has 16 different codes. See? And when it came with type 3, you thought that it was just one message, destination unreachable message, but it has 16 different codes. When you see code 0, it means that the destination network was unreachable, while code 1 means the destination host was unreachable. Now if you know the difference between network and host, you would understand. Host is the end system. So when it comes with a code, type 3 is there. Type 3 is for both, for the 0, code 0 and 1. But code specifies what actually is the problem. Let's see. Code 0, network was unreachable. Code 1, the host is unreachable. Now the PC knows exactly where the problem is. The third field are 2 bytes that are used for checksum to see if ICMP header is corrupt or not. Let's say any header you see the word checksum, it is normally used to see if the data integrity, if the data is corrupt or it is valid. How it checks that? It does it through a mathematical calculation. If the same value of the checksum while sending is received, it matches both the values. If it is the same value, then the data is not corrupt. What the remaining part of the header looks like depends upon the ICMP message type. Now be careful, type and not code. Why? Because let's say it's type 3, destination unreachable, then it can have a code of up to 16 different codes. Now I'll try to put in some examples at the end of this video for you to understand. I'll give you some examples and I'll put them there. I'll give you an example of pinging, and I'll give you an ICMP echo reply of type 0, code 0 and destination unreachable. I'll also try to put in a trace route example at the end so that you get it. If we talk about codes, okay, there are a lot of codes. If we type about types, 0 I told you it's echo reply, 1 is unassigned, 2 is unassigned, 3 is destination unreachable, 4th is source quench, 5th is redirect, 6th is alternate host address, 7th is unassigned, 8th is echo, 9th is router advertisement, 10th is router solicitation, 11th is time exceeded, 12th is parameter problem, 13th is timestamp, 14th is timestamp reply, and we got information request as 15th, 16th is in the information reply, address mask. So basically if you are going to go into this, they are up to 255. There are 255 types and you don't need to actually learn them all. If you know 8 or 9 or whatever is required by you, that is fine. Now The good thing is 44 to 252 is unassigned, so you don't have to learn so much. Now there is the 255th last number is reserved. So you don't actually have to learn each of them. You should know the basic ones like 0 is echo reply, third is destination unreachable. These are basically used in common day-to-day life of a network administrator or whoever is working on it. So I'll put in the examples. Let me give you a conclusion that you have seen what ICMP is used for, what the headers look like, and some of the most popular messages look like. If you have any questions, feel free to leave a comment and subscribe to my channel. I'll give you the replies. And after this, I'm going to put all those about destination, unreachable, and pinging, and all those things. Thank you very much. Bye bye.